All right, everybody. Hello, my friends, and welcome to day number 8 of the 66 days of data with KNIME challenge that we're doing. 66 live streams straight in a row talking about data science using the wonderful tool KNIME. And today and tomorrow, it's once again back to school, so to say, because we're going to talk about descriptive statistics. We're going to learn a little bit about the definitions of descriptive statistics, which will then help us later this week or later in the second category. I'll come to that in a second. Basically, to understand what our data set is looking like so that we can understand our data sets better, which I guess is a pretty good approach to work with data. So let me just quickly share with you where we are right now. So let's switch to the screen like this. All right, here we are. We are here on the 66 days of data KNIME page, and that is linked in the description down below. And we already can check off the first category, import data. That's what we worked on last week. Now we're in the second category, descriptive statistics. So let's have a quick overview what it is all about, and then we dive a little bit deeper into today's task or today's learning, so to say. So delve into basic statistic measures and find out things like average popularity of songs, highest danceability, plus the ever popular topic of missing values. That sounds promising, doesn't it? As I said before, we're working with the Spotify dataset that we downloaded in the last week from Kaggle. We did that in the very first session. If you missed that, I linked the video up above here. So let's just jump to that, and we're in day 8. So learn about basic statistic measures: mean, median, mode, variance, standard deviation, range, and quantiles. What is the difference between average and mean, and between variance and standard deviation? So let's have a look. I looked at a few of those links, and I have to say, well, the first link unfortunately is not working anymore, as I can show you. So that leads to deleted this medium story. Okay. But there is other good stuff, and that is basically this second link, this link here. It's this descriptive statistics introduction. So I don't want to read all of this aloud with you. I just want to go through the main sections. So basically, what we first want to look at are mean, median, and mode. And what I like about this page here really a lot is that it has some examples here. So mean, or the letter M, is the most commonly used method for finding the average. To find the mean, simply add up all response values and divide the sum by the total number of responses. So, one disclaimer, what I have learned so far from reading other sources as well is that that description is not 100% correct, because it's exactly the other way around. If you add up all the numbers in a data set and divide them by the total number of responses, you have the average. But the mean is basically the average can also be a subset of the data. If you're always looking at the whole data set, mean and average may be the same, but my understanding from what I have read is that mean is the average of a subset of data. So that's also answering the question, what's the difference between average and mean? But nevertheless, I like this page a lot because it does a very good job in explaining it. So if we have these numbers here, 15, 3, and so on, we add them together and get a result of 57. We have 6 numbers, n equals 6, and dividing the 57 through the 6, divide the sum of values by n, that results in 57 divided by 6, and that's 9.5. So the mean of this data set would be 9.5. The median is the value that's exactly in the middle of the data set. And why is that not similar to the mean? Well, my take on this one, and excuse me please, I'm still a little bit suffering my COVID sometimes. The median, it is maybe not evenly distributed, and that means the exact middle does not have to be equal to the mean. That's the median. The median is the value that's exactly in the middle of the data set. To find the median, order each response value from the smallest to the biggest. then the median is the number in the middle. If there are two numbers in the middle, find their mean. So we have 0, 3, 3, 12, 15, 24. The middle numbers are 3 and 12. So find the mean of the two middle numbers. 3 plus 12 divided by 2. The mean is 7.5. All right. And then finally, and you know, the one thing I struggled with at the beginning here in this task was, wait a minute, 0, 3, 3, 12, 15, 24. I couldn't take the 12 because it's an even set of numbers, right? If we would have 0, 3, 3, 12, 14, 15, 24, then 14 would probably, or the 12 would probably be our mean number. And finally, we have mode. Mode is simply the most popular or most frequent response value. A dataset can have no mode, one mode, or more than one mode. Okay, in this set, it's obviously the 3. It's the one that the response that comes most frequent. So 0, 3, 3, 12, 15, 24. Find the most frequently occurring response. That's 3. So these were mean, median, and mode. And that was, I would dare to say, probably the easy stuff. So let's go a little bit into measures of variability. And measures of variability are quite important because they tell you a little bit more about the whole data set, right? Is it very dense? Is it very together, all very close to one area or in one cluster if you want? And we come to that cluster part later on in this challenge. Or is it very widespread? So the range is the first kind of KPI that we're looking here. And the range gives you an idea of how far apart the most extreme response scores are. So that means what are the outliers if you want. So if we see a range of visits, so simply subtract the lowest value from the highest value. So 0, 3, 3, 12, 15, 24, subtracting the lowest from the highest is a range of 24. That's the range between the lowest and the highest. If we would have 1 and 47, the range would be 46 because we would subtract 1 from 47. So that's the range. That basically shows us both ends, or gives us an understanding in a set of numbers. If we have percentiles, for example, we could have a range ranging from 10 to 90%, then our range would be 80. All right. Next one, and you might have heard this one before, standard deviation. The standard deviation is the average amount of variability in your data set. It tells you on average how far each score, so each response, each number, lies from the mean, which we talked about, the average if you want, but we want to call it mean. The larger the standard deviation, the more variable the data is. It means the more distributed, maybe is the right word here. It is. So there are 6 steps for finding the standard deviation. So you see, more steps, it gets more complicated. So list each score and find their mean. Subtract the mean from each score to get the deviation from the mean. Square each of these deviations. Add up all of the squared deviations and divide the sum of the squared deviations by n minus 1. N, once again, is the number of responses, and find the square root of the number you found. So let's just see. Standard deviations of visits to the library in the past year. So raw data. 15, if we remember that the mean was 9.5, so we have 5, if we do it for the first few rows, 15 minus is the visits, 15 minus 9.5 equals 5.5. Squared equals 30.25. Next, 3 minus 9.5 equals negative 6.5. Negative 6.5 squared equals 42.25, and so on and so forth. So the next step, we add up all the squares. Square numbers. That is 421.5. Then we divide the sum of the squared deviations by n minus 1. N, if you remember, was 6. We have 6 values in here. Minus 1 is 5, so that's 84.3. And then we take the square root of 84.3, and that's 9.18. So we learned that the standard deviation, 9.18, you can say that on average, each score deviates from the mean by 9.18 points. And that gives us a good indication. We, of course, have always to see this in relation to the numbers that we have. A standard deviation, or a S or a sigma, as they say, of 9.18 alone, from my understanding, doesn't tell you a lot. You have to look at the data, because if you know that your range in this case is basically 24, you know the standard deviation gets much more related to these numbers, right? Then we have variance. Variance is the average of squared deviations from the mean. Variance reflects the degree of spread in the data set. The more spread the data, the larger the variance is in relation to the mean. That means variance basically is a little bit like how far on average is each value from the mean. And that's the variance, and you can see how it is calculated here. So it's basically just one of the numbers we did before. So if the standard deviation is 9.18, we square that, the variance is 84.3. All right, so that covered basically all the numbers, except we also want to have a look at quantiles, and that's also basically a very good understanding, because we can use this in KNIME a lot if we want the machine, if we want to let the machine do the hard work. And unfortunately, this page has a lot of advertisements for German railways on it. Excuse that, I cannot turn it off. But yeah, so maybe okay, so let's we can use quantiles in KNIME quite a lot if you want the machine to structure or bucket order, if you want, our data. So the word quantile comes from the word quantity. In simple terms, a quantile is where a sample is divided into equal-sized adjacent subgroups. That's why it's sometimes called a fractile. It can also refer to dividing a probability distribution into areas of equal probability. So it basically builds categories, clusters, if you say, but equal clusters. That's very important here. So how do you find the quantiles? Order the data from the smallest to the largest. The data in the question is already in ascending order. So we have this one here. Count how many observations you have in your data set. In this particular data set, we have 40 items. Convert any percentage to a decimal for Q. We are looking for the numbers where 20% of the values fall below it. So convert that to 0.2. Insert your values into the formula. So if you look at it, it's basically, let's just see. Can we understand that? The observation Q equal Q bracket n plus 1. So that's 0.2, the formula for the quantile. So we want to have basically, I'm sorry. We basically want to have but 20% of the values fall below it. So that's 0.2, then 40 plus 1, and plus 1 equals 8.2. Is at 8.2, so we round it down to 8, remembering that the formula is an estimate. The 8th number in the set is the 13, which is the number where 20% of the values fall below it. So if we wanted to have, for example, let's say the quantile where 60% fall below it, we would basically do the same. Order the data, count how many observations you have. We have that, we have 40 items. Convert any percentage to decimal for Q. So if we had said 60%, that would be 0.6. So the formula would be 0.6, and then 40 plus 1 equals, let's just do the math here quickly in a calculator. Just a moment. So what we basically want to do, 40 plus 1 is 41, of course. So we would say 0.6 times 4 to 1. And that would be 24.6 rounded up. That would be 25. So basically, we would say the 26 number here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Excuse me for counting with me. 21, 22, 23, 24, 25, 26. So basically here, I'm sorry, 24 was the number that 25 was the number that we were looking for. 24.6 rounded up is 25. So 60% of the value fall below 92 or lower, and that's how you determine the quantile. All right, there was a little bit of mathematics, and we will do another math session tomorrow, so to say, where we cover then the second part, where we learn about complex statistic measures like skewness and kurtosis. Before we then later this week, we cover the Data Explorer, which is a fantastic tool, and then we deal with missing values. So that was a little bit a longer stream. It was less NIMing and more talking, but that's just somehow the way it is. That's part of the 66 days of data challenge that we want to do. So I hope you enjoyed it, and that we will see each other back tomorrow when we do day number 9 in 66 days of data with KNIME. Thank you.